Thank you. I'm so happy for this wonderful moment together again. So here we're going to look at exciting topic on stoichiometric. If you look up here, you will find out that we have some calculations, equations we have already on the board, and special thanks to our subscribers. They are making us, in fact, they are motivating us to do more. Because when I look at that, it makes me believe that actually we are making an impact, and that's the only reason we are here to make sure we impact in lives. And here again, we are going to look at some of the easy ways of taking care of stoichiometric calculations in chemistry. So here we have a equation here. Stoichiometric. Most times, stoichiometric we look at it because it always tells us something um, balanced chemical equation. It can also tell us the volume of the reactants and the products, and also the mass of the reactants and the mass of the products. In some cases, we see it as mass volume relationship because it tells us it gives us a qualitative analysis of the reactants and the products that are involved in a chemical reaction. So we want to look at this as a case study of how we can look at how we can take care of calculations involving that. So in this case, in the first one, we have nitrogen reacting with hydrogen to give us ammonia. In this balanced equation, as you can see from here, you will notice that in this balanced equation, is saying that from the stoichiometric coefficient of this, it means that 1 mole of nitrogen combined with 3 moles of hydrogen to give us 2 moles of ammonium gas. So because they are all gases, we then consider the molar volume. The molar volume, which is always 2.4 dm cube, or in some cases we say it was liter, 22.4 liter. So based on that, it means that since they are all gases, you can say that 22.4 dm cube of nitrogen will combine with 67.2 dm cube. That means 3 multiplying 22 will give us this of what hydrogen to give us 44.2 grams of volume of ammonia. So all these things are what in volumes, dm cube in volumes. That is 22.4 dm cube combined with 67.2 dm cube, and to produce what 44.2 dm cube of what ammonia. So from here now you can see the relationship they have of the reactants and then the product. This relationship governs everything that you are going to do. Well, be it let's say we have maybe 2 grams of this combining with this, what it will give us will remain on the same ratio based on the on this number of moles of the reactants and the products. Now another one we have here, we have another one. This one has to do with mass and volume. For the hydrogen, this is potassium triazochlorate, 5 decomposing, 2 moles decompose to give us 2 moles of potassium chloride and 3 moles of oxygen. In the same vein, this is, remember the molar mass. From the molar mass, we know that reacting masses is mole times what molar mass. So the number of mole multiply the molar mass of this, we have this other one here. We have 245 grams of potassium decomposed to give us 149 grams of potassium chloride, and then oxygen we have 67.2 dm cube because it's a gas. So in this case now you find out that every combination you see here circles around the ratio. They have the mass, everything, they are all in ratio. So from a balanced chemical equation, we can see the mass of the reactants and the products that we have, and also we can also have the we can also detect or predict the volumes of the reactants that we can see, just like what we have from here. So we're going to look at some a few maybe a question to look to help us understand this better. All right. What we're going to do now is, so in this question they say that calculate the mass of potassium hydroxide required to prepare 500 cm cube of 0.2 mole per dm cube of solution. That means this can also be look at as the molality. Do you understand? That means the molality of the solution that we need to prepare this is what 0.2 mole. Is that okay? So now, so what we're going to do here is that the first thing we're going to find out is the mass. We're looking at the mass. Because we're looking for the mass, we need to know the mass that is contained in this. We need to find out the mass of the thing of the potassium hydroxide that is contained in these two 0.1 mole, 0.2 mole. Now we know that molar mass of potassium is, molar mass will be potassium plus 16 and then plus 1. If we add up this thing, what we have there should be equal to 56 gram per mole. That is what we have there. So, and what again we're looking out for? We know that the volume required is what? Cm cube, and then the molality or the concentration in what mole per dm cube of solution is what 0.2 mole, and so what this simply means is that in 1000 cm cube or 1 liter of the solution we have this, but we want to know what its equivalence when we have if we are to prepare 500 cm cube of the same from this mole. So what it means here is that it means that 1000 cm cube 1000 cm cube 1000 cm cube of potassium hydroxide contain, now we're going to convert it to mass, because we are looking for the mass. Since we are looking for the mass, we will go over to the mass. That means mass now will be 0. This times 2 times what? 5, 6. That will give us 11.2 grams of what? Potassium. That is 11.2 grams of what? Potassium. So what are we going to expect in 500? This is another exciting thing we're going to find out. To do that, I think in 500, what we do now, that means 500 cm cube. We then, the mass that will be required there should be over 1000 times 500 over 1. We can cancel out. We cancel out. Then we can also cancel out this one. Cancel out that. What we have finally will look like this. This one will give us to what we have finally should be like this, 5.6 grams of what potassium, that is 5.6 gram of what potassium hydroxide. That means if you add 5.6 gram of potassium in 500 cm cube of a solution, you will get the concentration that will be equivalent to this in that small quantity of this thing. Thank you so much. Thank you. I want you to subscribe for the channel and like also, and leave your comments and then make sure you share. And the next video that's coming up will give us more this now. I'll make sure I organize it in playlists so that to give you more details about everything you need to know about stoichiometry. Thank you so much for watching. Thank you.